In the name of Allah, the Beneficent, the Merciful. Welcome to the world of physics. Due to coronavirus, we have to continue our online class. I'd like to suggest you stay home, stay safe. Today, we are going to discuss about the chapter 9, and name of the chapter is refraction. And at first, observe this diagram and now think what you have observed in this diagram. It's a kind of refraction that is going to be happen in this diagram. A wave comes from another one medium to other medium, and then it refracted to another medium. And here the incident angle is alpha and refracted angle is beta. And the two medium is denoted by C1 and C2. That's all shown in this diagram. Okay, now today we are going to learn about all these topics. That is image formation by concave and convex lens, power of lens, defect of eyes, critical angle, and total internal refraction. Actually, critical angle and total internal refraction, both the topic that you have learned in previous class, in class 8, and it's very much easy for you to understand what is critical angle and what is total internal reflection. And a third topic is completely related to our previous chapter, that is reflection of light. And in reflection of light, we have discussed about the image formation by concave and convex mirror. And here the difference is, in this chapter we only discuss about the image formation by concave and convex lens. That's all the difference between previous lecture and today's lecture. In previous lecture we have learned about mirror, and in today's lecture we will just replace the word mirror with the word lens, and some of the differences that will be discussed in our lecture. And learning outcomes by the end of this lesson, we will be able to explain total internal reflection and critical angle, and describe image formation by the lens, and describe the power, and describe the defect of eyes. These are the learning outcomes. And key points of today's lecture is critical angle, total internal reflection, converging and diverging, erect, inverted, diminished, and power. These are the some of the new term that is introduced here, and we are going to discuss all these key points in our lecture. And first topic is critical angle and total internal refraction, and second topic is rules of image drawing, image formation by convex lens, power, defect of eyes, and last topic is home task. And now our first topic is critical angle, and here the definition of critical angle is shown, and critical angle is denoted by theta c, and during the passing of the light from denser medium to the rarer medium, the angle of incidence for which refraction angle becomes 90 degrees is called critical angle. And here theta c in the diagram, theta c denotes critical angle, and here the refraction angle is 90 degrees. This is the only condition for making critical angle, that is refraction angle is 90 degrees and the light ray comes from denser medium to the rarer medium. Our second topic is total internal reflection, and in total internal reflection, observe these what's happening in the in this diagram. And here, definition of total internal reflection is here we have to maintain two conditions, that is light ray must come from denser medium to the rare medium, and second condition is the incidence angle is greater than critical angle. In previous slide we have discussed about critical angle, and if we apply the angle incident angle that is greater than critical angle, then the angle is what will happen here? Yes, here total internal reflection will happen if the incidence angle is greater than critical angle. And here we must maintain a condition, that is the light ray must come from denser medium to the rare medium. Okay, then I think that is clear by observing this diagram and the definition, and here the condition also shown in this diagram. And now I'm trying to solve this. Here we have a question for you, that is light incidence at an angle of 75 degree from a medium of refractive index 1.45 with what angle will the ray of light emerge if there is air on the other side? Here the equation is shown, that is n1 sin theta 1 is equal to n2 sin theta 2, and all the values are given here, and by putting this value we can calculate the result. And here the angle, that is I is greater than theta c, then total internal reflection will happen in this condition. And the light ray comes from denser medium to the lighter medium, and it is better to check critical angle, because if the incident angle is greater than critical angle, then total internal reflection will happen. Here another diagram for you, that is a ray comes from denser medium to the rare medium. Here the denser medium is water medium and rare medium is air medium, and for A we have for incident ray A we have refracted ray A prime, and for incident ray B we have refracted ray B prime. And by following these condition you can solve this question. Here first question is what is the refraction of light, second question is when total internal reflection take place, explain, and calculate the velocity of the light in B medium. Here we have to use the equation, that is eta V is equal to CA by CB. By using this equation we can get the velocity of the light in B medium. And number two equation is if air medium is in the stem is replaced with glass medium, is it possible to find the total internal reflection? Analyze drawing required figure. Here if we place the air medium with the help of glass medium, then the condition will not happen here. For the condition of total internal reflection, we know that the light ray comes from denser medium to the rare medium, but if we put the denser medium in the upper side of water medium, then the light ray doesn't come from denser medium to rare medium, rather it will come from rare medium to denser medium. That's why the total condition for total internal reflection will not happen if we put glass medium instead of air medium. And we can draw the diagram because we know if a ray comes from rare medium to denser medium, the ray will be inclined towards the normal, and if it is come from denser to rare medium, then it will go beyond the normal, and we can draw this diagram. I think all of you have such knowledge of uh, drawing the such diagram for if the light ray comes from rare medium to denser medium or denser medium to rare medium. And here we have to put only the condition, that is the light ray comes from denser medium to rare medium to denser medium. Here these all are the condition and rules for drawing of ray diagram. Here are 3 rules for drawing ray diagram. Rays of light incident in a direction through the optical center of lens is refracted along the same straight line without any deviation, and ray incident on the direction parallel to the principal axis after the refraction process. And here through the principal and the refraction passes through the principal focus, and for convex lens it will be diverse, and for concave lens it will be converged. And if a ray of light incidents through the principal focus in the case of convex lens are directed towards the principal focus. In the case of convex lens, after the refraction through the lens becomes parallel to the principal axis. Okay, we are going to show all these 3 rules by using diagram. Here the rules of drawing ray diagram in lens. Here first rule is if a ray comes towards the center towards the optical center, then it will go towards the optical center. And second rule is if the incident ray is parallel to the principal axis, then it will go through towards the focus of this lens. And if the incident ray is through the focus, then the refracted ray will parallel to the principal axis. And these all are the 3 rules. We show this by using ray diagram. And here in the upper side, these all the rules for convex lens, and for concave lens the rules is shown in the bottom side of this diagram. Here okay, that's all the 3 rules. By using these rules we can identify the position of the object. Here if the object at infinity, then this is the condition for the formation of image at the focal point, and object position in infinity, and image will be formed at focal plane, and nature of the image is real and inverted, and size of the image is extremely diminished. These all are the information for this condition if the object is placed at infinity. And here the magnification is nearable to 0. That's all the information. And if the distance less than focal length, if the object is placed inside the focal length, then a image will be formed, that is the object position between optical center and the focus, and the image position is same side of the object, and the object is a virtual and erected image, and size of the image is bigger than the object, and magnification is greater than 1. Here in your book will show, you will get a diagram that's shown in the slide in upper right side. Okay, this all of the information for the distance less than the focal length. If the object is placed that distance that is less than focal length, then we will observe such diagram. And if the object is between infinity and the center of curvature, here the object is placed between infinity and the center of curvature, then we will find a diagram here. To draw a diagram, we have to draw by using the rules of ray diagram. That is, if the incident angle is parallel to the, if the incident angle is parallel, then the refracted angle will, then the refracted ray will go through focus, and if the incident angle is go through focus, optical center, then it will go through in the same way. Here, by using these two conditions, we can draw, this is the position of the object and this is the position of the image, and by using this, the object position is between infinity and the center of curvature, and the image position is between focus and the center of curvature, and the image is real and inverted, and the size of the image is small, and refraction and the magnification of the image is less than 1. This is the third diagram that we have discussed. Our fourth diagram is, if the object is placed at the center of the curvature, then the image will be formed at the position center of the curvature. Here, the nature of the image is real and inverted, and size is equal, and the magnification for this diagram is 1. Here, this is the fourth condition for drawing image by using ray diagram. Here, the object placed at the center of curvature, and the image will be formed at the same position, that is center of curvature, and the nature of the image is real inverted, that is equal, and the magnification is equal 1. Our next condition is if the object placed in between focus and the center of curvature, then we will find a diagram that object is placed in between focus and center of curvature, and the position of the image is between infinity and the center of curvature, and nature of the image is real and inverted, and the size of the image is bigger than the object, and here the magnification is greater than 1. This all of the information for the object that is between focus and the center of curvature. I think this all the pictures and all the diagrams is so much relatable with the chapter that we have discussed in our previous classes, that is a reflection of light, and here the chapter is refraction of light, and only difference for this, is in reflection of light we discuss all these diagram for convex and concave mirror, and here we discuss this diagram only for lens. And if the object is placed at the focus, that is point F, and we will find the position of the image that is at infinite position. Object position is focus and image position is at infinity, and the nature of the image is real and inverted, and size of the image is extremely magnified, and magnification is double greater than m double greater than 1, and that is much more 1, and much more magnified image will be formed if the object is placed at the position focus. And here a diagram that is for convex, we have discussed 6 conditions for convex lens, and if we here our next discussion is all about concave lens, and if the object is placed inside the focus or any other position, that then by using the condition for ray diagram we can draw the position of the image. Here the xy is the position of the object, and x prime y prime is the position of the image, and the object position is inside the focus, and the image position is between optical center and focus, and nature of the image is virtual and erect, and the size of the object is image is small, and magnification is less than 1. And for every condition of concave lens we got the same image, that is virtual, erect, and the size of the image is small. this I repeat that is for concave lens, the nature of the image for all the condition for the position of the object, that is the position of the image is virtual, erect, and the size of the image is small, and the magnification is less than 1 for every condition for the position of the object in concave lens. But in convex lens, the position and the nature of the image have changed for the position of the object, but in concave lens the position and nature and the size of the image will remain same, that is virtual, erect, and small, and the magnification is always less than 1. That's the difference between convex lens and concave lens. In convex lens, the image position, nature and size and magnification of the image is directly related and directly related to the position of the object, but in concave lens, for all the position of the object, the image position, nature, and the size will be same. That's the only condition. I hope you have understand the difference for drawing convex and convex lens. And the sign convention that will be helpful for you to solve mathematical problems. That is, if the object is a real object and real image, and we put the value positive, and the virtual object and virtual image we put the value that is negative. For focal length, for convex lens, that is f is positive. For concave lens, that is focal length is negative, and for magnification it might be minus v by u, that is, and the distance of the image for real image is positive, and the distance of the virtual image is negative. And if the value of the m is less than 1, that is inverted image, and if the value of the m is positive, then the image is erect. I think this diagram will help you to solve mathematical problem by using the sign convention. For your better understanding, if you find any difficulties in my lecture, then you will ask me any question in our class time. Okay, and for better understanding, you may take a screenshot of this slide to solve mathematical problems. And the power of the lens, that is P is the equation is P is equal to 1 by F, and here the capacity of a lens to convert a parallel beam of light into a convergent beam or into a divergent beam is called power of lens, and the reciprocal of the focal length of the lens is called power of the lens. And the equation is P is equal 1 by F, and here P is inversely proportional to the focal length of the lens, and the unit of the power of lens is diopter. And here two diagram is shown in the below, and focal length for both lens 10 centimeter and focal length for both lens 12 centimeter. And if the focal length is greater, then the power will be decrease with the increase of focal length. Here power of the lens is more, cause here the focal that is the value of f is less than the other, and here the power of the lens is less cause the focal length is greater than the previous one. I hope you can differentiate between both these diagram. If the focal length is less, then the power will be greater, and if the focal length is greater, then the power will be less. And function of an eye, and our eye lens is a convex lens, and it makes inverted image form in our retina, and the sensation of is transmitted to the brain by the optical nerves. The brain then there infers the inverted image in the retina, and we can see the object in its real shape and size. And we can face some defect of vision, and we have some remedy also. If the defect is short sight, and the problem is we cannot see any object, distance object and object distinctly, but we can see anything in near distance directly. And cause of the object problem is the radius of the eyeball is increased, and the focal length decreases, and the power of the convergence of the lens increases. That is, and for the remedy purpose we use convex lens, and the sign of the convex lens is negative. And if we face a problem that is hypermetropia, then the problem is we can see any distance object distinctly, but cannot see anything anything of near distance distinctly. And for this cause, the cause of the problem is the radius of the eyeball is decreased, and the focal length increases, and the power of the divergence of the length eye lens is decreases. And for the remedy purpose we use convex lens, and the sign of the convex lens is positive. This all of the information for the defect of vision and its remedy and correction of defect vision. For remedy purpose we use a spectacle of convex lens for short sight, and for long sight we use convex lens, and for short sight, that is myopia, we use a concave lens for remedy purpose. By using this concave lens, we can get see clear image on the right on the retina. And if here we can see the object from near distance, but we can see the object that is far from us. Then by using this lens that is shown in the second diagram, by using this lens that is concave lens, we can get a image that is formed in the position of retina, in the exact position. Then we can see the position of the object that is far from the object stands in the far position. Here from far distance the image comes from, and for this object we see the image that is inverted image, and it formed in retina. Here by observing this diagram we can say that for myopia or short sight we use concave lens here. And this is the image. And if we face hypermetropia, then we can say that we can see the long distance object, but we cannot see the near object. And for this purpose, to see the object clearly, we use a convex lens before our eyes to have to form an image in the position retina. And for the remedy purpose of hypermetropia, we use convex lens. And at a glance, we have here discussed about critical angle, total internal refraction, and image formation by concave and convex lens, power of lens, and defect of eyes. And types of question. I think you can pause the video here because I'm not taking enough much more time in this slide. And here some of the knowledge level question is shown. I think if you solve all these questions, then it will be helpful for you to solve every problems that will be faced in our next exam. It's one kind of suggestion, and the types of question for knowledge level questions and comprehension level questions. Try to solve all these questions, and I think it's much more easier for you to solve all these questions. That is, what is image, what is real image, what is virtual image, what is principal focus, what is magnification, what is focal length, what is reflection, what is optical center, what is refractive index, what is critical angle, what is total internal reflection. This such kind of easy and memorization based question, that is knowledge based question, and some of them are comprehension based question. I think if you try to solve this, then it will be helpful for you to get a good marks in our next exam. And okay, I'm going to our next slide. And if you want to take more time, then pause the video here and try to solve all the question that is knowledge based and comprehension based. And types of question for application based, here observe this diagram, and types of question for high availability question. I will suggest you to pause the video here to solve these application based question and high availability based question. I think all of you can solve this problem. And if you find any difficulties, then ask me in our class time. Then it will be very easy for me to address where you have find difficulties. Okay. If you want to take more time, then pause the video here and try to solve this question. And here I have a question for you. That is a MCQ sample question, and try to solve this question. First question is, what is the value of perception value of vision of the eye? That is 0.1 second. And though our main lecture have finished, and here's some sample question, MCQ question, and pause the video here and try to solve these MCQ questions. Okay, you may take 3 minutes time to solve these 5 questions. You can pause the video here and try to solve this question. I think if you solve all these questions, then it will be helpful for you to understand the motive of my class. And if you are able to solve all these questions, then you can solve the board question, and it will be helpful for you to get to take good preparation for exam. And let's see home task, and here is a home task is shown for you, and you may take time to solve this question and pause the video here, or take a screenshot of these of the slide and try to solve this question. And okay, I'm reading. First question is, what is optical center? I hope you know the definition of optical center. And second question is, why is the use of optical fiber easier for the transmitted signal at far places? And it's also easy question for you. And third question is, calculate the power of the lens of the spectacle of person A. We know for the power of the lens, we use the equation, that is P is equal 1 by F, and by using this equation P is equal to 1 by F, we can find the power of the lens of the spectacle of the person 1. And last question is, explain with ray diagram how the lens of the spectacle of the person B forms image. I think by using ray diagram, we can draw the position of the object, position of the image for the person B. And try to solve this question. That's all for you. And I think all of you have understand my class, and thank you for with us. And try to make a 20 MCQ question based on today's discussion, and the assignment will be opened on Thursday. That I'll give you in our official website. And you may have some question. Okay, if you have any question, then please write in the inbox, and you can call me, or you can call me in our class time or any other time to solve your every problems. And here are the tips for COVID-19 prevention tips. Okay, read all these tips that will be that is very essential. That is, wash your hand, cover your face, avoid contact, and make social distance. And that's all for you. Thank you for joining with us, and I think all of you have understand our today's class. And stay home, stay safe. Once again, Allah Hafiz.